Hi, I'm Shana McKay from Scaffolded Math and Science. This is my session on making math visual using cut paper. I hope you enjoy it. Here I'm going to lay out 9 squares to show 3 squared is 9. And in our little chart here, we'll write that 3 squared equals 9. Now if I divide by 3, so I take 2 of these columns away, I have 3 to the 1 is 3. If I divide by 3 again, so take 2 of these away, I get 3 to the 0 equals 1. If I then use my scissors to divide this piece by 3, take 2 away to divide by 3, I get 3 to the negative 1 is 1/3. And if I then use my scissors again to divide this piece by 3, this 1/3 divide that by 3, I find that 3 to the negative 2 is 1/9. I put this little sheet in the downloads file so that students have a reference to look at. You've definitely seen the visual proof that the interior angles of a triangle equal 180 degrees. So I'll start with the triangle that I know you've seen before, and we'll rip off the corners. And we can see that those 3 angles equal 180 degrees. We can extend it to a quadrilateral. And see that the sum of the quadrilateral's interior angles are 360 degrees. And we can even extend it to a pentagon. To show that a pentagon's interior angles will add up to 1 full circle and 1/2 circle, so 360 degrees plus 180 degrees, so 540 degrees. We can show geometric reflections over the y-axis, over the x-axis, and even over the y equals x line using a template and a hole punch. So first I will reflect over the y-axis. I'm just going to fold along the y-axis, use my hole punch, and punch into the vertices of the shape. When I open it back up, my shape is now over here in quadrant 1, and I can just attach these holes here. Oh, draw on the table a little bit. And there is our quadrilateral reflected into quadrant 1, reflected over the y-axis. I can reflect into quadrant 3 by reflecting it over the x-axis. And there is my reflected shape. Then I can reflect it over the y equals x line by folding it along that line and using my hole punch again. And there is our reflected shape. This one comes in handy. Oops, I missed. This one comes in handy when you're talking later about inverse functions. I can even show rotations using a hole punch. Here I have my same template, but I cut this part of the y-axis so that I can bend the paper to show the rotation. So I'm just going to bend it around the origin into quadrant 1, so a 90-degree rotation. Use my hole punch. And I have my rotated shape. Counterclockwise rotations are very similar, except I'm going to cut here along the x-axis so that I can rotate my shape from the second quadrant into the third quadrant, because that'll be a 90-degree rotation, counterclockwise rotation. Line up the axes. Open it back up, and there is my counterclockwise 90-degree rotated shape. We can also show 180-degree rotations. For this, in order to get this shape into this quadrant, I need to remove this piece of the grid just so that the paper isn't in the way when I turn the shape. Okay, so now I'm going to just bend this around, line it up as best I can, and hole punch. Open it up, and there is my 180-degree rotated shape. You can use a hole punch to also investigate inverse functions. So here I just have a blank grid. I had folded it along the y equals x, and I'm just going to pick any point in any quadrant, and let's see, maybe 1, 1, 4, and record it on my little recording sheet over here. Now when I fold along y equals x and I hole punch, the point that I hole punched is 4, 1. Let's do it again with another point, maybe here. Fold it, see if I can reach that point with my hole punch. There we go. So I have to record this one, so -1, -2, -3, -3, 4, and we have 4, -3. One more, maybe here. So 1, 2, 3, 4, 5, -5, -1. fold along y equals x, hole punch it, and we have -1, -5. Students might start to see that when we fold along the y equals x line and hole punch, we kind of swap the x and y values. So this will start going into inverse functions. Here is the line 2x plus 4. And let's see what line we create when we fold along y equals x to find the inverse of y equals 2x plus 4. Okay, so we have a line like this. And we can see that this is up 1 over 2. And if we were to find algebraically the inverse of 2x plus 4, we would swap x and y and solve for y. Which is what we got with the hole punch. Same with the quadratic. This quadratic in vertex form is y equals x plus 2 squared plus 1. Fold along y equals x. Hole punch our coordinates. And we get a kind of sideways parabola. The kids might say that this isn't a function, and they're right. If we just look at this half, we'll start to see that it's a radical function. We see x minus 1 inside, and then minus 2. And because we have entire parabola here, we're going to have our plus minus outside. And if we were to find the inverse of y equals x plus 2 squared plus 1 algebraically, we would find that this would be its inverse. Let's say I wanted to find the square root of 19. I know that the square root of 19 is somewhere between the square root of 25 and the square root of 16. To show square root of 19, we can add 3 more of these little squares, 17, 18, 19. And we see that 1, 2, 3 out of the total 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to get to square root of 25 are filled in. So we can say that the square root of 19 is about 4 and 3 out of 9. So about 4 and 1/3. Let's move this square root of 25 away and just look at this part. Okay, so this doesn't really look like a square number. It's a square, and then it has some extra little purple squares on the side. So I'm going to cut each of those little squares into thirds so that I can spread them around the square root of 16 to make it kind of like a square. We have one left over, just a little piece will fit into that little space. And because this is an approximation, we're going to have a little bit left over, so if I were to cut this and spread it around, we would end up with the square root of 19. So about 4 1/3. If you were to do it on the calculator, square root of 19 is about 4 1/3. Let's use the square root of 36 and the square root of 25 to approximate the square root of 30. To get from square root of 25 to square root of 30, we would need 5 more of these spaces filled in. Move 36 out of the way. Okay, so the square root of 30 is about 5, and 1, 2, 3, 4, 5 out of the 5, 6, 7, 8, 9, 10, 11 spaces. So it's about 5.5, a little bit less than 5.5. Because this isn't a square, I'm going to cut these in half and kind of fill it in as the square to show the square root of 30. Okay, this is about the square root of 30. It's just kind of a approximation. Of course, the square root of 30 is not exactly 5 and 5/11ths, but it's a pretty close way to show it visually. Thank you so much for watching my session on making math visual. I hope you enjoyed it. You can find more resources and blog posts and freebies and other ideas at scaffoldedmath.com. Bye.